how's it going, guys? My name is Donaven Jordan. I know we have to get out a visual aid before class, well, beforehand, so I'm giving out my visual aid now. I have a requirement of audience again. My mom, Michelle, my sister, Kiara, and my sister, Tristan. They all each meet the age requirements of 16 years old. And first off, I want to talk about the assemblage of the light above. The assemblage of the light above. I know it doesn't sound spectacular or spontaneous or out there, but this is something that I know. Have you ever wondered what it's like to see the outside sources of bright lights, in our sky? Let alone understand where these lights even come from. Well, this theory is all thought into one, and as I should say, throughout age, all these scientists became all these different ideas of how the Earth started, how the moon started, and how we've seen those lights. And that has to come with the Big Bang Theory. Long ago, a massive explosion happened. And that explosion, well, the energy of that explosion was so massive, it started to make gigantic clusters of light. And within those clusters of light, there were many star formations. And those star formations turned into galaxy formations. And those galaxy formations turned into protoclusters. And now a protocluster is a bunch of little lights in the sky, well, stars in the sky, all brought into one to form one galaxy. As we know, the Milky Way galaxy, where we live in now. In the Milky Way galaxy, there's multiple galaxies like Andromeda, one right next to us, that comes to one, and that's a protoclusters. Multiple galaxies to one, they spread out, and this is where we at now, modern day Earth. So, the topic has been chosen because I know in the few and far between, the average person may have not heard of this information. So I have to say, well, I have to tell you that I think it should be important for you guys to know. Now, I got my information from, or research from a case study of the early star formations and formations of protoclusters. And this may include star formation, well, this included star formations from the beginning of the star, the middle age of the star, and the ending of the star. Now, the ending of the star varies either from turning to a black hole, either a white dwarf, which our sun is going to turn, but it just depends. I know at the birth of the star, gas condenses. There's a bunch of stardust in the sky right now, a bunch of filled with molecules and atoms that gravity then brings together, and it undergoes this immense pressure, and we call that protostar. In that protostar, before it becomes a full star, it reaches an accretion disk. That accretion disk is just the friction around the star that just barely makes it into a star alone. Now, after the star is done forming the accretion disk, it releases a solar wind. And that solar wind right now is what we have outside of our asteroid belt, and that is the Oort cloud. I know if you guys haven't heard of that, we're in the Orion Nebula. And this is the stardust that the sun has actually formed. We can actually study that. Now, after the star is done and it reaches, after its protostar stage, becomes a full star, aka the sun. And the only way that the sun, well, stars can be fueled is by hydrogen having a nuclear reaction with helium. And that happens throughout, it varies between the sizes of stars, but it happens throughout billions of years, 5, 10, 15 billions of years. The bigger the star, the shorter its life. The smaller the star, the longer its life. I know our sun says that it has about a life expectancy of 5 million or 5 billion years left. So we'll be long gone after that, but that's what they say in the case study. As I was saying about the bigger stars, they can either form into a black hole because they have so much iron and rate inside of them, or they can have the sun itself that reaches to a red giant, which will happen, and that'll become in itself. Right now, we have talked about the star formation cycle. Now let's consider the longevity and uniqueness of the star. to say studying these massive, gigantic structures gives a better understanding of the concepts of galaxies and how life itself began. Now, I would have to thank my family for being here. My name is Donaven Jordan, and I thank you.